So after applying column by column addition, we will get this result. But here's the thing, as we started with 4 bits and we extended to 8 bits by multiplying it with 2. So if we have 4 bits, as I said, we will use 8 bits. If we have 8 bits, we will use 16 bits. So here in our case, we start with 4 bits and we extend it to 8 bits. So at the end, we will just need 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So this is our answer. And here is a thing. After you reach to 8 bits, there is like no need to perform the other column by column addition to save some time. Okay, so this is our first method, which is sign extension method. And now we will move to our next method, which is Booth's algorithm. And this one, it reduces the number of additions and subtraction when there are consecutive ones or zeros. So let's complete with our numbers, which are -7 and -5. First of all, we transfer them to their two complements form, as we discussed before. So for the -7, we have 1001, and for the 5 we have 1011. And for the multiplication, here's the thing, like you can like swap the numbers and you will get the same result. And for the sign extension, we move from we shift the bits from right to left, but for the both algorithms we do the opposite things. We shift from right to left. So let's complete our answer. So I will start from the right now. We do something like this, and here I will write the 5, 1, 0, 1, 1, and here's the 7, 1, 1, 1, 0. The reason that I swapped them, because the 7 contains more zeros, so I put it here. So for in both algorithms, I prefer to do this. And then we have to put the second number here, okay, which will be the 7, 1, 0, 0, 1, and as we did in the previous method, if we have 4 bits, we extend it to 8 bits, and if we have 8 bits, we will extend to 16. But here's the thing, and instead of extend it, we will with 1, 1, 1, we will just add 0, 0, 0, and 0, just in both algorithms. And so let's get started. First of all, we put the 7, the second number here, and we will add 0 here. Why we should add 0 here? To say what the operation that will happen, what operation that we will perform. So we have 3 different cases. If we have 1, 0, we will add the second number, which is the 5, will be addition. Sorry, I made a mistake. If we have 1, 0, will be subtraction. subtraction. If we have 0, 1 will be addition, and if we have 0, 0 and 1, 1, we will do nothing. So first of all, let's make a quick revision. We put the numbers -7 and 5. Then we move the second number here, and then we add. We don't add 0, like we add 0 here, just to know which operation that we perform. So in this case, we have 1, 0, which will be subtraction. We subtract the second number from the 0, 0. Sorry. We put the second number here. We add 0 to see which operation. And here we add zeros here to make the 4 bits to be 8 bits number. So we will subtract 1, 0, 1, 1 will be subtraction because we got 1 and 0. So here we don't have anything, so we will just put it as it. 1, 0, 0, 1. Here we have 0 minus 1. We can perform it, so we need to borrow. So let's assume there is 1 here, so we will borrow 2. And so here, instead of the 0 here, we got 2. We will borrow 2 from it, so we borrow 2, so this will be 1 and here will be 2. We borrow 2 from it, so this will be 1 and this will be 2. We borrow 2 from it, so we got 2 here. So here we have 2 minus 1 will be 1. Here we have 1 minus 1 will be 0. Here we have 1 minus 0 will be 1. And here we have 1 minus 1 will be 0. And we don't think about the other numbers. So we will move on now. So after every operation we shift to the right. So for the shifts I will use the blue number, the blue color. So here we do a shift. So in the last number we have 0, so we will add 0 to the last number. So here we got 0, 0, 1, 0. And this one will move here, so we will have 1, 1, 0, 0. And this one we will move it here, and the 0 we will ignore it. So here we have 1. So we did our first operation and our first shift. So here we have 1, 2, 3, 4 bits, so we will do 4 shifts. The number of shifts equals to the numbers of the bits that we have. So let's see the next case, which is 0, 1, which is addition. So we will add the second number, 1, 1, 0, 1. So here we don't have any number, so we will add it as it. We'll put it as it 0, 0, 1, 1. Here we have 1 and 0 addition, sorry. We'll have 1. 1 plus 1 equal 2, so we'll put 0 here and we carry 1. 1 plus 0 will be 1. And here 0 plus 1 will be 1. So we did our second operation, which is addition. So now we will make a shift. But here's the thing. Here we have 1. So in our shift we will add 1 to the last number. So here we have 1. So here will be 1, 1, and 1. This one that we added. And the last one will be here 0. And for this one we will move it here. So here we will have 1, 1, 1. Here we have 0. And this 0 we will move it here, and we'll ignore the 1 because it will be out of our scope. So here we will have 0. And we did our second shift. Which is here. Now we will see the case. Here we have 0, 0. We will do nothing. So we will put the number as it. Here we have 1, 1, 1, 0. 1, 1, 1, 0, 0. And we will shift. Here we have 1, so our shift will be by adding 1 to the last position. 1, 1, 1, 1, and the 0 will be moved here. So here we have 0, 1, 1, 1, and the 0 we will move it here. And by that we did our third shift. Now we will see the case. Let me change the color. Here we have 1 and 0, which is subtraction. So we will subtract the first number, which is minus 5. 1, 0, 1, 1. Here we have 1 minus 1 will be 0, 1 minus 1 will be 0, 1 minus 0 will be 1, 1 minus 1 will be 0, and here we have no number, so we just put it as it, 0, 1, 1, 1. Okay, now we will perform our last shift, which is the fourth shift. Here we have 0, so we will add shift to the last position. Here we will have 0, 0, 1, 0, and this 0 will move it here. So here we'll have 0, and 0, and 1, 1, and here we will have 1. Okay, so this is our last and fourth shift, and the number that we got is this one we will ignore it also, because it is just for the operation that we will perform. So here we have 1 multiplied to the power of 0, or we will make it like this. Here we have 2, 1, here we have 2, 4, 8, 16, 32, and here we have 0, 0, so we will ignore it. So here we have 32 plus 1 plus 2, so the result will be 35, and the most significant bit is 0, so it will be plus. So here is our result, 0, 0, 1, 0, 0, 0, 1, 1 in the true complements form. Okay, and now we will move to our next method, which is Robertson method, and it is another way to do binary multiplication using shift and conditional addition. It is a little bit similar, but to the Booth's algorithms. So I'll try to explain it here. Robertson method. We will perform this method with our numbers. which is -7 and -5. Okay, so here we have 1 0 0 and 1. Here we have 1 0 1 1 in the two complements form. So here is the thing with the Robertson method. We ignore the last bit, or the most significant bit, or the sign bit of the second number, and we perform a normal multiplication. So here we have 1 multiplied by 1 multiplied with this number will be 1 0 0 1. We move to the second bit and we do shift to the left. Let's compare with the second, with the same color. We have 1 multiply with 1. So here, sorry. Here we have 1 0 0 1. And the last thing, which is 0, we do a shift 0 0 0 and 0. Okay, so this is the first step. We ignore the most significant bit, or the sign bit of the second number, and we perform a multiplication. And then after performing the multiplication, we can notice that there's a gap here for two numbers and a gap here for one number. So the thing is, here we have 1, so we will add 1 and 1 here. Here we have 1, so I will add 1 here. If we have a 0 here, I will change this to 0. For example, if we have 0 here, I will put this 0, but this is not our case here. So here I have 1, so I will add 1 here. And now we do a simple addition. Here I have 1. 0 plus 1 will be 1. 0 plus 0 plus 0 will be 0. 1 plus 1 plus 0 plus 0 will be 1. 1 plus 1 will be 2 plus 0. So here I put 1 and I have 1 here. The carry is 1. 1 plus 1 plus 1 will be 3, so I put 1 here. And the carry is 1 here. So I will write the carry bit. So as a result, we have 1 1